Hello. So now we are on our last topic for this chapter. So the last topic is SQL injection. So to start, SQL injection is a code injection technique that's used to attack data-driven applications in which malicious SQL statements are inserted into an entry field for execution. So an example of this is when um, an SQL statement is entered or inserted to dump the database contents to the attacker. So SQL injection must exploit a security vulnerability in an application's software. So two examples are when user input is either incorrectly filtered for string literal escape characters embedded in SQL statements, or when user input is not strongly typed and unexpectedly executed. So SQL injection is mostly known as an attack vector for websites, but can be used to attack any type of SQL database. So the SQL injection attacks allow attackers to spoof identity, tamper with existing data, cause repudiation issues such as voiding transactions or changing balances, allow the complete disclosure of all data on the system, destroy the data, or make it otherwise unavailable, and become administrators of database server. So here are the examples of SQL injection. So for SQL in web pages, it is usually a placement of malicious code in SQL statements, usually via web page input, right? So it usually occurs when you ask for or when you ask a user for input, like their username or user ID. And instead of username or ID, the user gives you an SQL statement that you will unknowingly run on your database. SQL injection based on batched SQL statements. So most databases support batched SQL statements. So a batch of SQL statements is a group of two or more SQL statements separated by a semicolon, right? So how do we detect SQL injection? So um, we have these series of different techniques on how we could detect different SQL injection. So first one is open source tools. So to make detecting an SQL injection is attack easy, developers have created good detection engines such as SQL Map or SQL Ninja. And then next we have source code analysis tools. So these are also referred to as static application security testing or SAST tools that are designed to analyze source code and or compile versions of code to help find security flaws. These tools can automatically find flaws such as buffer overflow flows, SQL injection flaws, and others. So you can detect and prevent SQL injection by using a database firewall. So database firewall are a type of web application firewall that monitor databases to identify and protect against database specific attacks. These attacks mostly seek to access sensitive information stored in databases. So when you work with database firewall, SQL injection filtering works in the same way, similar to email spam filters. So the database firewalls detect SQL injections based on the number of invalid queries from a host, while there are OR and union blocks inside of the request or others. So we also have use prepared statements. So the use of prepared statements with variable binding, or also known as parameterized queries, is how all developers should first be taught how to write database queries. So they are simple to write and easier to understand than dynamic queries, right? So parameterized queries force developer to first define all the SQL code and then pass in each parameter to query later. So this coding style allows the database to distinguish between code and data regardless of what user input is supplied. Prepared statements also ensure that an attacker is not able to change the intent of a query, even if the SQL commands are inserted by an attacker. So the next one is use stored procedures. So the stored procedures are not always safe from SQL injection. However, certain standard stored procedure programming constructs have the same effect as the use of parameterized queries when implemented safely. So this is the norm for most stored procedure languages because they require the developer to just build SQL statements with parameters, which are automatically parameterized unless the developer does something largely out of the norm. So the difference between prepared statements and stored procedures is that the SQL code for the stored procedure is defined and stored in the database itself, and then called from the application. So both of these techniques have same effectiveness in preventing SQL injection. So your organization should choose which approach makes the most sense for us. And then the next one is whitelist input validation. So various parts of SQL queries are not legal locations for the use of bind variables, such as the names of tables or columns and the sort of order indicators such as ascending or descending. So in such situation, input validation or query redesign is the most appropriate defense. So for the names of the tables or columns, ideally those values come from the code and not from the user parameters. But if the user parameter values are used for targeting different table names and column names, then the parameter value should be mapped to the legal or expected table or column names to make sure an unvalidated user input does not end up in the query. So please note, this is a symptom of poor design and a full rewrite should be considered. And then the last one that I will be discussing is the escaping all supplied input. So this technique should only be used as a last resort. So when none of the above are feasible, input validation is probably a better choice as this methodology is frail compared to other defenses and we cannot guarantee it will prevent all SQL injection in all situations. So this technique is to escape user input before putting it in a query. Its implementation is very database specific. So it is usually only recommended to retrofit legacy code when implementing input validation is not cost effective. Applications built from scratch or applications requiring low risk tolerance should be built or rewritten using parameterized queries, stored procedures, or some kind of object relational mapper or ORM that builds your queries for you. The escaping works like this. So each database management system support one or more character escaping schemes specific to a certain kind of queries. So if you then escape all supplied input using the proper escaping scheme for the database that you are using, the database management system will not confuse that input with SQL code written by the developer, thus avoiding any possible SQL injection vulnerabilities. So there are some libraries and tools that can be used for input escaping. So an example for this is OWASP or Enterprise Security API or ESAP or is which is a free open source web application security control library that makes it easier for programmers to write lower risk applications. So the ESAPI libraries are designed to make it easier for programmers to retrofit security into existing applications and serve as a solid foundation for new development. So there are also some additional defenses that can be considered. So we have least privilege, multiple database users, and SQL views. Let's tackle them one by one. So for the least privilege, so to minimize the potential damage of a successful SQL injection attack, so we consider here that the injection was already done. You should minimize privileges assigned to every database account in your environment. So do not assign DBA or admin type access rights to your application accounts, right? So we understand that this is easy and everything just works when you do it this way, but it is really very dangerous. So start from the ground up to determine what access rights your application accounts require, rather than trying to figure out what access rights you need to take away. Make sure that accounts that only need read access are only granted read access to the tables for which they need access. So if an account only needs to access to portions of a table, consider creating a view that limits access to that portion of the data and assigning the account access to the view instead, rather than under the underlying table. So early, if ever, grant, create, or delete access to database accounts. So if you adopt a policy where you use stored procedures everywhere and do not allow application accounts to directly execute their own queries, then restrict those accounts to only be able to execute the stored procedures they need. Do not grant them any rights directly to the tables in the database, because SQL injection is not only threat to your database data. Attackers can simply change the parameter values from one of the legal values they are presented with to a value that is unauthorized for them, but the application itself might be authorized to access. Minimizing the privileges granted to your application will reduce the likelihood of such unauthorized access attempts, even when an attacker is not trying to use SQL injection as part of their exploit. You should also minimize the privileges of the operating system account that the DBMS runs under. Do not run your DBMS as root or system, because most DBMS run out of the box with a very powerful system account, right? And then for the next additional defense, we have the multiple database users. So web applications designers should avoid using the same owner admin account in the web applications to connect to the database. Different DB users could be used for different web applications. So in general, each separate web application that requires access to the database could have a designated database user that the web app uses to connect to the database. That way, the designer of the application can have detailed access control, thus reducing the privileges as much as possible. Each DB user will then have select access to what it only needs only, and write access as needed. And then lastly is the SQL views. So you can use SQL views to further increase the access detail by limiting read access to specific fields of a table or joins of tables. So it would potentially have additional benefits. So Mm, for example, suppose that the system is required to store passwords of the users. So instead of salted hashed passwords, the designer could use views to compensate for this limitation. So revoke all access to the table from all database users except the owner or admin, and create a view that outputs the hash of the password field and not the field itself. So any SQL injection attack that succeeds in stealing DB information will be restricted to stealing the hash of the password. because no database user for any web application has access to the table itself. Right. For the next one, we have OWASP. So let's define first what is OWASP. So the Open Web Application Security Project, or OWASP, is focused on providing education, tools, and other resources to help developers avoid some of the most common security problems in web-based applications. So some of these resources include tools, code projects, and documentation projects. So for tools, OWASP produces tools such as the Z attack proxy or ZAP, which looks for vulnerabilities during development. OWASP dependency check, which looks for vulnerabilities in your code, and Defect Dojo, which streamlines the testing process. For code projects, they were able to create the mod security CRS or core rule set. So generic attack detection rules that can be used with web application firewalls and OWASP CSRF guard, which prevents the cross-site request forgery or CSRF attacks. And then for documentation projects, OWASP is perhaps best known for its documentation projects, right? Because it includes the application security verification standard, the top 10, which describes the top 10 most security issues in the web applications, and the cheat sheet series, which explains how to mitigate those issues. So let's look at the most common of those top 10 issues. No, let's look at the top 10 directly. So here are the top 10 attacks for as described by or as compiled by OWASP. So for injection, this item consists of all in sorts of injection attacks. So we have talked earlier about SQL injection, but this is only the most common. All databases such as LDAP database, Hibernate database, and others are potentially vulnerable. So in fact, any action that relies on user input is vulnerable, including direct commands. So you can mitigate these types of attacks by using parameterized APIs, escaping user input, and by using limit clause to limit exposure in the event of a breach. We also have broken authentication for number two. So this item relates to multiple problems with user credentials, from stolen credentials database to default password shipped with the product. So you can mitigate these attacks by avoiding default passwords, by requiring MFA or multi-factor authentication, and using techniques such as lengthening waiting periods after failed logins. Third is sensitive data exposure. This item refers to when attackers steal sensitive information such as password or personal information. You can help prevent these attacks by storing as little information as possible and by encrypting the information you do store. For fourth, we have XML external entities or XXE. This item refers to attacks made possible by a feature of XML that enables users to incorporate external information using entities. We can solve this problem by disabling XML entity and DTD processing, or by simply using another format such as JSON instead of XML. For broken access control, so this item refers to the need to ensure that you have not built an application that enables users to circumvent existing authentication requirements. So for example, attackers should not be able to access admin functions such just by browsing directly to them. So in other words, do not rely on security through obscurity. Make sure to protect all resources and functions that need to be protected on the server side, ensuring that any and all access really is authorized. Sixth, we have security misconfiguration. This item refers to the need to ensure that the system itself is properly configured. Is all software properly patched and configured? Is the firewall running? Prevention of these types of problems requires careful, consistent hardening of systems and applications, and then reduce the attack surface that is available. So to do this, only install the services you actually need and try to separate out components that are not related to different systems to reduce the attack surface further. For seventh, we have cross-site scripting or XSS. This item refers to the ability for an attacker to use the dynamic function of a site to inject malicious content into the page, either in a persistent way, such as within the body of comments, or as part of a single request, right? So mitigating these problems requires careful consideration of where you are including untrusted content in your page, as well as sanitizing any untrusted content you do include. Eight, we have insecure deserialization. So these items describes issues that can occur if attackers can access and potentially change serialized versions of data and objects. That is, text versions of objects that can be reconstituted into objects by the server. So for example, if a user's information is passed around as a JSON object that includes their access privileges, they could conceivably give themselves admin privileges by changing the content of that object. Because objects can include executable code, this exploit can be particularly dangerous, even if it is not necessarily simple to exploit. So to help prevent issues, do not accept serialized objects from untrusted sources. Or if you must, ensure validation before deserializing the objects. For the ninth attack, we have using components with known vulnerabilities. One of the advantages today's developers have is that most of the core functions you are trying to perform have probably already been written and included in an existing software package. So it is probably open source, right? However, many of the packages that are available also include publicly available exploits. So to fix this, we have to ensure that we are using only necessary features and secure applications downloaded from official sources and verified with a signature. And then for the last attack is the insufficient logging and monitoring. So this item reminds us that our most basic responsibility is to ensure that we are logging everything important that is happening in our system so that we can detect attacks preferably before they succeed. It is particularly important to ensure that your logs are in common format so that they can be easily consumed by reporting tools and that they are auditable to detect or better yet prevent tampering. So those are all the top 10 OWASP attacks. Right. So next we have let's jump into the evolution of passwords. Right. So over the years, there is an evolution as well of the password in systems. Right. So before we have the simple plain text passwords. So the first passwords were simple plain text ones stored in databases. So this allows multiple users using the same core processor to have a unique privacy settings. So the for plain text passwords is very simple. Just store them. You have a database with a table for all your users, and it would probably look something like ID, username, and then the password. So after the account is created, you store the username and password in these fields as plain text, and on login, you extract the row associated with the input username and compare the input use password with the password from the database. So if it matches, you let your user in. So perfectly simple and easy to implement, right? And then we have the next generation, which is password hashing, right? So storing passwords is risky and complex at the same time. So a simple approach to storing passwords is to create a table in your database that maps a username with the password. So when a user logs in, the server gets request for authentication with a payload that contains username and a password. So we look up the username in the table and compare the password provided with the password stored. A match gives us the user access to the application, and then the security strength and resilience of this model depends on how the password is stored. So the most basic, but also the least secure, password storage format is clear text. Storing passwords in clear text is equivalent of writing them down in a piece of digital paper. So if an attacker was to break into the database and steal passwords table, the attacker could then access each user account. So this problem is compounded by the fact that many users reuse or use variations of this single password, potentially allowing the attacker to access other services different from the ones being compromised. So the attack could come from within the organization. A software engineer with the access to the database could abuse that access power, so retrieve the clear text credentials and access any account. And then the next evolution is hashing. So a more secure way to store password is to transform it into a data that cannot be converted back to the original password. So this mechanism is known as hashing. So by definition, hashing refers to chopping something into small pieces to make it look like confused mess. So that definition closely applies to what the hashing represents in computing. So in cryptography, a hash function is mathematical algorithm that maps data of any size to a bit uh, string of a fixed size. So this function input can be referred to as message or simply an input. The mixed size string function output is known as the hash or the message digest. So as stated by OWASP, hash functions used in cryptography have the following key properties. So one, it is easy and practical to compute the hash, but difficult or impossible to regenerate the original input if only the hash value is known. And then also, it is difficult to create an initial input, but that would match a specific desired output. So thus, in contrast to encryption, hashing is a one-way mechanism. So the data that is hashed can practically be uh, unhashed. Yeah, that's the term, unhashed. Right. So the next generation is the salted password. Right. So there are many passwords that are encrypted but can be guessed. Right. They have been mined from hack sites and placed into lists. So these lists have made hashed passwords work much easier to crack. To guarantee the uniqueness of the password, we have to increase their complexity and prevent password attacks even when the inputs are the same. So a salt, which is simply random data, is added to the input of a hash function. This is known as the uh, salted password. And then we have using cryptography hashing for more secure password storage. So the irreversible mathematical properties of hashing make it a phenomenal mechanism to conceal passwords at rest and in motion. So another critical property that makes hash functions suitable for password storage is that they are deterministic. So a deterministic function is a function that given the same input always produces the same output. This is vital for authentication because you need to have the guarantee that a given password uh, will always produce the same hash. Otherwise, it would be impossible to consistently verify user credentials with this technique. Right. So Next is we have here a combined, so adding salt to hash, password hashing, right? So a salt is added to the hashing process to force hash uniqueness. So it increases complexity without increasing user requirements and mitigates password attacks such as rainbow tables. So in cryptography, salting hashes refers to adding random data to the input of hash function to guarantee a unique output, which is the hash, even when the inputs are the same. So consequently, the unique hash produced by adding the salt can protect against different attack vectors while slowing down dictionary and brute force attacks. And then we also have adding factors for authentication. So even with the incorporation of these passwords strength checkers, single factor authentication still leaves your enterprise vulnerable. So hackers can crack any password. It may take significant time, but they can. So moreover, they could always steal passwords via social engineering. All right. So you should incorporate multi-factor MFA, and then incorporating other authentication factors can found hackers who may have cracked your password. So our next three, or I think these are all the latest, right? Factor authentication. So we have three. First is single factor authentication, which is the simplest form of authentication methods. So with SFA, a person matches one credential to to verify himself or herself online. The most popular example for this of this would be password to a username. So most verification today uses this type of authentication method. Online sites can have user passwords leaked by a hacker. So without an additional factor to your password to confirm your identity, all malicious user needs all a malicious user needs is your password to gain access. So hopefully it is not a website that has additional personal information stored, such as your credit card information, home address, or other personal information such used to identify you. Often a user's password is simple so that it is easy to remember. So the simpler the password, the easier it is to crack, right? And then we have two-factor authentication, or 2FA. So two-factor authentication uses the same password username combination, but with the addition of being asked to verify who a person is by using something only he or she owns, such as a mobile device. Putting it simply, it uses two factors to confirm an identity. And then the last, or the most uh, latest password system that we use is the multi-factor, or MFA authentication. So it is a method of computer access control in which a user is only granted access after successfully presenting several separate pieces of evidence to an authentication mechanism. Typically, at, the, at least two of the following categories are required for MFA. Number one, knowledge of something they know, or possession of something they have, and inherence, which is something they are. So 2FA, as discussed a while ago, is a subset of that. So it is just a type of MFA where you only need two pieces of evidence, at least two factors, when you log into. So that's about it for the evolution of password systems. So the last topic that I'll be discussing for this chapter would be the password cracking, right? So these are techniques used for finding a password that allows entry, which is known then as cracking. So cracking the security intended by the password. Right. So the first one is password guessing. So it is an online technique that involves attempting to authenticate a particular user to the system. Password guessing may be detected by monitoring the failed login system logs. So clipping levels are used to differentiate different malicious attacks and normal users accidentally mistyping their passwords. Right. So the clipping levels defined in a minimum report threshold level. So password guessing, using uh, using the password guessing example. So a clipping level might be established so that the audit system only alerts if failed authentication occurs more frequently than 5 times in an hour for a particular user. The clipping levels can help to differentiate the attacks from the legitimate mistakes. However, they can also cause fake negatives if the attackers can glean the threshold beneath which they must operate. Right. So the next one is dictionary attack. So in cryptanalysis and computer security, a dictionary attack is a form of brute force attack for defeating a cipher or authentication mechanism by trying to determine its decryption key or passphrase by trying hundreds or sometimes millions of like possibilities, such as the words in a dictionary. So a dictionary attack is based on trying all the strings in a pre-arranged listing typically derived from a list of words such as in a dictionary, hence the phrase dictionary attack. And the third one, we have pre-computed dictionary attack or rainbow table attack. So it is possible to achieve space trade-off by pre-computing a list of hashes of different words and storing these in databases using the hash as the key. So this requires considerable amount of preparation time but allows the actual attack to be executed faster. So the storage requirement for the pre-computed tables are once a major cost, but are less of an issue today because of the low cost of disk storage. Right. So the pre-computed dictionary attacks are particularly effective when a large number of passwords are to be cracked. The pre-computed dictionary needs to be generated only once, and when it is completed, password hashes can be looked up almost instantly at any time to find the corresponding password. And then the last one is social engineering techniques. So this is very common, especially on my field. So for password cracking, which involves social engineering, it involves a person convincing or tricking another person into supplying the attacker with access. So employer behavior can have a big impact on the information security in organizations. Cultural concepts can help different segments of the organization work effectively towards information security. All social engineering techniques are based on cognitive biases, where humans make decisions based on known or assumed attributes. Cognitive biases are exploited in various combinations to create attack techniques such as stealing an employee's private information. Phone calls and conversations are the most common types of social engineering. Right. So there are four social engineering vectors or lines of attacks that can take advantage of these influence principles. First one is phishing. So phishing means the person is fraudulently gaining information, especially through requests for financial information. So often the attempt looks like a real website or an email, but linked to a collector site instead. Right? So usually phishing has the sense of urgency, requesting you to do something and supply them with the information that they need to steal some information from you. We also have phishing, which stands for voice phishing. So it is associated with the voice phone calls to gather private information for financial gain. So this is usually common to the scenario of hackers. Usually, when they try phishing, they ask for something urgent, and if they pretend to be someone that you know and you have provided them with such information without verifying if they truly were, the hacker is actually her friend. So um, what happens there is they have provided without doing some confirmation if that was really um, his or her friend. Right. So next one is smishing. So it involves using SMS text messages for both urgency and asking for specific course of action, such as clicking a fake link or sending account information. So this is really common, especially when you are using postpaid plan, right? So recently, I have been receiving different texts from different numbers asking for some information or sending an email to somebody, so things like that. So it's connected to smishing. And then for the last one, we have impersonation. So it involves in-person scenarios such as wearing a service provider uniform to gain access inside the building or any system. So those are all the different password crackings that we have. Right. So I think we have officially completed all of the topics that needs to be discussed. So before we end this video, I'd like to share some key points that are key takeaways that I took from this chapter. So first is environments help application development transition from one phase to another without interruption between them. So this provides the different stakeholders to perform their tasks without dependency to others. Each software has different purpose. So depending on how it processes, there are different modes in which these are to be deployed, depending on the need, right? So the businesses have a unique architecture and are specially made to help run their company. The landscape deployed varies to the involved systems, which caters how the processes inside these components are being run. And then in terms of how companies choose the flow of every change or program, they adapt to the standards that they have set and or the processes that they are comfortable with. And then security doesn't just mean you have the best security software in place, right? So the first barrier that everyone should have to protect their data is their company is for each employee to practice vigilance and caution, especially when dealing with people outside the project or the company. So I think that's the end of my report. I hope everyone has learned a lot from this chapter. Thank you.